Okay, thank you for that introduction. Welcome everybody to the insights of our study. I'm very happy to be able to present you the key findings of this report. So as said, it's about metals for clean energy. It was really the idea of this study for Euromezzo and its members to get a better perspective on what the Green Deal has as implications for the European metals and mining industry. And we will take in this study first a demand perspective to then go to the supply options. But let's take it one by one. Now, this is not new to the audience that the energy transition is a commodities transition. And it is also not super new that the fact that the faster that the world decarbonizes, the more metals it needs. And in this study, we also did a quantification of how much that would be. Now, in the study for climate scenarios, we used the energy outlooks of the IEA, the International Energy Agency, and we used their two main energy scenarios, one called the STEP scenario, which is about current climate policy, so the deployment of what is currently stated in the policy. And they also have a scenario of high climate ambition, the SDS or Sustainable Development Scenario. And we have quantified that in a STEPS environment, we need about 45 million tons of extra metal by 2050. But if we go to a high climate ambition, we need 1.7 times as much. We need 75 million tons of metal. That clearly indicates that the faster we decarbonize, the more metals that we need. Now, we all know as well that a lot of the clean technologies that we need to decarbonize our economy, batteries, electric cars, solar panels, wind turbines, that they all need metals. But as a result, and how they are deployed, they all have a different impact on all of those metals. And what you see here is an overview of how the metals that we had in scope are impacted. So just to be clear, Euromezzo, we had everything in scope except steel. Iron ore is not included. And the list that you see here are the metals, the non-ferrous metals that are impacted by more than 10%. The percent is the ratio of the demand for this metal in 2050 versus the total market in 2020. So lithium is on the top, 2,109%, sorry, which is actually saying that in 2050, we need 21 times today's market to make those clean technologies. Now, in this study, we focus a bit deeper on three groups. The first is the base metals, aluminium, copper, zinc, and silicon. These markets are impacted by 15 to 60%. The second group is the battery raw materials, lithium, nickel, cobalt. We see a very high pull on these commodities. And also the rare earth elements going to permanent magnets, dysprosium, praseodymium, and neodymium get a very strong pull from the energy transition. Now, this in itself are not super new insights. The IEA made a very good report about critical raw materials. Also, the World Bank makes good reports. But what is very new in this study is what impact does it have for Europe? Because until now, a lot of these clean technologies are built elsewhere. And yeah, the visual shows you clearly where that is. It's mainly Asia-focused, China-focused. But with the Green Deal, Europe has made very clear commitments on making a share of these clean technologies in Europe. With the European Raw Material Alliance, there's great ambitions on permanent magnets. There's the European Battery Alliance, there's the European Solar Initiative, there's also an initiative on wind turbines. And of course, if we say we're going to create those value chains in Europe, that has an impact on the metal demand. We want to accelerate and we want to do it domestically, so the European metal markets are going to be impacted. And then, of course, comes the question again, by how much? Now, starting with this first group, the base metals, and we take as example here aluminium. So the gray in the bars is the current demand end uses, and then the blue is what we need for those clean technologies. And assuming that for aluminium, we will need a lot of demand in EVs, solar and electricity networks, we see that it's going to rise from 14 million in 2020 to 21 million in 2050, largely driven by clean technologies. Now for battery raw materials, yeah, the story is more dramatic, obviously, because today in Europe, we hardly have lithium demand. And the lithium demand that we have is not for batteries. It's for the glass industry, for the ceramics. But if we are going to make our own batteries in Europe, we're going to develop a market for lithium, for battery grade lithium here as well. And the same story is for the permanent magnets and the demand for the rare earth elements. Now that brings, of course, challenges. If we have more demand, there's things to keep in mind. The first is, and we'll say it's also very timely in that sense, that we are reminded by the situation in Ukraine that there is something to say for strategic autonomy in our own metals. The second challenge is about sustainability, to find reliable, responsible partners that produce those metals in a sustainable way. And combining those challenges really comes the question of how can we as Europe bridge that supply gap? And this is what we'll handle in the second part of this presentation. And to show this, we have chosen for the visualization, of a bridge, because it explains well what we want to say. We know where we are today. On the left-hand side, we want to have an acceleration of our clean energy transition. And at the same time, we want to work on that strategic autonomy, to say by 2050 that we are decarbonized with good strategic autonomy and also a right level of sustainability. And for that, we say we have 5 pillars to get there. And actually those 5 pillars, we can again put them in 2 groups. Why? Because in the beginning of our energy transition, say now in the next 2 decades, we cannot really count on recycling yet, because you can only recycling metals that you have in the system. But as we're going to ramp up our metal demand quickly, well, those recycling reserves are not available yet. So the beginning of the energy transition we have to do with primary metal. And that's what the first 3 pillars are about. Europe has 3 options for primary metal. We can look at our domestic mining potential. That's pillar 1. We can look at our domestic metal production, refining potential. And pillar 3 is we can look at imports. Now taking them one by one. Pillar 1, the domestic mining potential. Europe has great ambitions for its new energy commodities. You might have heard already of lithium projects, so I'm sure you have actually, or rare earth element projects. But you might have heard less about copper projects and cobalt projects. And that is where we see on the mining side that Europe currently has 2 groups of metals with different dynamics. And we'll start with the first group with the positive dynamics, those new energy commodities, lithium, rare earths. What we see there is that they have big project pipelines, 10, 15 projects, which is in European terms a lot. And if we look at lithium specifically, it runs up to 130 kilotons of LCE of potential. The 130 kilotons of LCE doesn't say that much in itself, but it's helpful when looking at demand to express that in a self-sufficiency rate. And that is a self-sufficiency rate of 55%. Now, there is a risk, a serious risk, that despite that potential of 55%, that we actually reach 0%. Why? That is because we have a lot of announcements, but the projects are not advancing in a way that they're advancing in other regions in the world. They have several challenges. They have not much public support. They have permitting waiting times. For lithium specifically, they have really good sustainable technologies, but new, still to be proven technologies. And the costs are also expected to be high. As a result, these projects are not advancing and have a serious risk of not developing. And also in our base case scenario in this study, we assumed that lithium does not reach the potential. But it's very good to keep in mind that if we do manage those challenges, that we have a potential of 55%. Now the story is different on that second group of metals, cobalt, zinc, nickel, copper. What we see there is that we already mine those in Europe. And we also have projects for these markets, but when developing the certain projects, actually they don't compensate for depletion. The depletion, the running out of reserves in your pits, is bigger than can be compensated by new projects. So what you see here, for the example on copper, is that by 2030, there's a serious risk that the market declines by 13%. In terms of self-sufficiency, here we're talking about 11%. So we say for domestic mining potential, there is potential, but we do need more political support combined with high ESG standards to make it possible. On pillar 2 is the domestic refining output, the metal production. And also here, we see those two groups of commodities. We have on the one hand the struggling markets, and on the other hand the growth markets. Now this time we start with the struggling markets. The examples that we can put on paper here is the aluminium industry, the zinc, the silicon industry. The energy prices have been very high, and these industries have felt this, or your industry has felt this. As a result, we counted that in 2022, that about 10% of the aluminium capacity was temporarily put offline, and almost 40% of the zinc capacity. In addition, we've also seen that in the last year, the aluminium industry got protected by trade defense measures. Silicon is already in that position. As a result, we don't have expansion projects. And we actually have the contrary, what you can see below. We have a self-sufficiency rate for aluminium of 25%. But where there is no potential for growth, we actually see the opposite, that there is a risk of contraction if we're not able to manage these high energy prices and foresee that the permanent closures don't come, or the temporary closures don't come permanent. Now, as said, the two groups, we have the struggling markets, but we also have that growth potential. So the growth potential of lithium and rare earth is on the mining side, but it's also on the metal side. And we actually also see potential on the nickel markets. There is additional projects to add 25% or 24% to the current capacity, making a self-sufficiency rate of 59% for nickel. So on pillar 2, the metal capacity, we say, well, here there's also potential, more potential than on mining. We're not restricted to the geology, but we definitely need strong business conditions to make it possible for the current industries to survive and for the new industries to start up.